We're doing surds and manipulation of surds. In case you're just tuning in for the first time, these are GCSE revision videos suited to those people wanting to do GCSE in the summer. The idea is that you're just looking at a bunch of exam questions that I'm going to go through with you. If you want to see these topics from scratch, there's plenty of other YouTubes to look at, but this is about exam questions primarily. So it's probably going to be about 20 to 30 minutes long, just going through some of the fundamentals with this particular topic. And again, if you want to make comments on the video, please do so on the comment section below if you're watching on YouTube, or if you're watching it on Twitch, then you can do it on the chat bar, which is next to where the Twitch vision screen is. Okay, so let's look at this first question, and you can see it's quite an interesting looking question to do with right angled triangles. The key thing about this question is to read it really carefully. It's set out in a way that you will need to just be very cautious about where all the dimensions are. So we're going to go through this really carefully and just show you some of the pointers that you might want to look at. So first of all, it's talking about all the measurements here. This is the measurement of the base, and here we've got the measurement for the side. This is only the distance from C to D. In the question it does say that the distance from B to D, in other words this whole length here, is the same as this, so it's root 2 over 2. So I'm just going to scribble that in there just so that I've got it in my head, that this is root 2 over 2. That's something that the question states. It's not filled in for you, but it is stated in the question down there. It's asking for an area of the shaded region. So given that we've got triangles here, we're already thinking about the two formulas for the area of a triangle we have, which is half AB sine C, or half the base times the height. In this case, it's going to be half the base times the height because there are no angles mentioned. So ideally we're looking at half the base times the height here for each triangle. And the strategy to work out the shaded area will be, let's work out the area of the big triangle, this big one that I'm tracing with the pen. Let's work out the area of the little triangle, the little one here, and then just take the two things away. So take the area of the big triangle, take the area of the little triangle, take the area of the little triangle away from the area of the big triangle, and you'll have this shaded area. So in order to look at the big triangle, ABD, okay, we're going to look at that one first, triangle ABD, and we're going to do half the base times the height. So half of this, so root 2 over 2 is the value, so if we halve that, it's going to be root 2 over 4. So I'm just going to show the examiner that I'm doing that, root 2 over 4, and then times this height, so root 2 over 2. Now on the top we have, if you're multiplying fractions, you'll have root 2 times root 2, well, that's just 2. And then 4 times 2, well, that's 8, so that's a quarter. So the area of the big triangle, this big one here, is a quarter centimetres squared in this case, because it does say all measurements given in centimetres. For the little triangle, the triangle ACD, so that's the little one, this one here, we're going to do the same thing, and again, just demonstrating to the examiner which one we're talking about. I'm going to do half the base again, so it's still the same thing, so root 2 over 4, but this time the height is different, it's root 3 over 3. So root 3 over 3, and then we've got these two things multiplied, so root 2 times root 3, well, that's just root 6, and then 4 times 3 is 12. This is about as simple as it gets, and 4 3 is 12, so as simple as it gets. So in terms of my area of my shaded area, I'm going to just move this up slightly so you can see what I'm writing. So the shaded area here will be this one, the quarter, minus root 6 over 12. And I'll put that in brackets and put centimetres squared, and that will do. It doesn't ask for it in a particular form. You can simplify this a little bit by having a common denominator and writing it as a single fraction, but to be honest, the answer scheme will probably have a variation on these answers, and this is probably one of them, so I'm happy that this is the answer for now. So just leaving that as an expression in the first instance is one of the lessons you learn from this. It doesn't have to be simplified any further, you don't need to do anything more. It's asking for an exact area, this will be it. You don't use a calculator to work it out. I'm assuming this question was in the non-calculus paper. Even though it's a surd, you can leave it in surd form. Okay. Question 2 I've pulled out is to do with another area question, but this one to do with a trapezium. So again, for the area of the trapezium, you're going to do half the sum of the parallel sides. So these are the parallel sides here. So half of the sum of those, and then times by the distance between them. So times by this. So half the sum of these times by the perpendicular distance between them. So these two added up, divided by 2, and then multiplied by this. So we've got to write that all down in some sort of succinct logical way. So we're going to do root 5, and then add up the root 5 plus 6. We're going to halve that, because it's half the sum of the parallel sides, and then times by the distance between them, root 5 minus 2. I'll leave that in brackets for now. Let's look at this first. So we've got 2 root 5 here, and then over 2. So 2 root 5 divided by 2 is just, well, root 5, and then 6 divided by 2 is 3. So we can simplify that. We'll just write the rest of the sum for now. So again, looking at one step per point, we're going to do root 5 plus 3, and then put that in a pair of brackets, and then we've got the other bracket, root 5 minus 2. So root 5 minus 2 from up there, and this is root 5 plus 3. Now we're looking at a pair of brackets, which we need to multiply using our full method or our brackets method or whatever method you're keen on using. I personally like the full method, so I'm going to probably work along those lines. So the first 2 terms multiplied would make, well, just 5, because root 5 times root 5 is 5. The outside terms would be minus 2 root 5. The inside terms would be 3 root 5, and then the last 2 terms multiplied makes minus 6. You've got to be really careful with your signs on these questions. Minus 2 root 5 plus 3 root 5 is just root 5, and then you've got 5 minus 6 here, well, that's going to be minus 1, so you end up with root 5 minus 1, and it's in centimetres squared, so that would be the answer that you would write in there. So root 5 minus 1. Again, just some little pointers. Just be really cautious about this. Some people don't like working with surds, and it's important that you're doing the same methods that you use for multiplying pairs of brackets. So I've done another video on expansions, which is dealing with mostly x squareds and things, quadratics. So if you would like to have a little hint and tip about how to work with pairs of brackets, then just take a look at that video on the Maths Jedi channel. Question 3, again, working through this one, we're going to do this real carefully. This is again just a pair of brackets, so I've got root A and root 4b, root A and 2 root b. Well, this is kind of a deceptive question, because this particular thing here can be simplified, because I've got root 4b here. This can be simplified. Root 4 is 2, so I could actually rewrite this question as root A plus 2 root b, and then root A minus 2 root b. Okay, so this effectively is the same thing as this. So just be very cautious about what I've done there. I've done the square root of 4, pulled it outside the square roots, that's 2. The square root of b remains the square root of b. The other bracket remains unchanged. So I've rewritten the question slightly. Why have I done that? Because you can see that you've made it a lot easier now, because we can use the full method for this again. So first 2 terms multiplied, well, that's just a, square root of a times square root of a. Outside terms, minus 2 square root of a, square root of b. Inside terms would be plus 2 square root of a, square root of b. And then the last 2 terms, careful with the signs, minus 4 times b, because root b times root b is b. These 2 things, you can see they're the same. One's a minus, one's a plus. So this is going to cancel out, leaving you with a minus 4b here. So a, and then minus the 4b at the end. And that would be the answer for this question. Again, it's not massively difficult. Really easy to do once you see that sort of simplification to do. You could go about it using the root 4b, but it would be a lot harder, but you would get there eventually if you did a little bit of simplification. So in terms of the answer, it's just seeing that you can simplify the question a little bit. And again, it's just full method expansions. So again, same tip. If you're a bit stuck on expansions, there's another video for that. on my channel. Right, question 4. Let's have a look at this. So this one again is a pair of brackets, very similar. These are all very similar. So again, we do first two terms multiplied, that's 3. Outside terms multiplied, that's minus root 2. Inside terms multiplied, that's 3 root 2. And then last two terms multiplied, that's minus 2. Root 2 times root 2 is 2. And then 3 minus 2, well that's just 1. And then minus root 2 plus 3 root 2, well that's like minus x plus 3x. So minus x plus 3x, that's going to make 2x. So you're going to have 2 root 2. So you've got 3 minus 2, that's 1. And then you've got 2 root 2. And that is in the form that it's asking for. A and B here. A would be 1 and B would be 2. Very simple. That's why it's only worth 2 marks. This one here, again, these are all really similar. We're just using form method again, so first two terms multiply, just be really careful to multiply everything. So 2 3s are 6, root 5 times root 5 is 5, so you've got 6 times 5, that's 30. So the first two terms multiplied make 30, so just do that again for you. It's 2 root 5 times 3 root 5, so you're doing 2 3s are 6, root 5 times root 5 is 5, 6 times 5, 30. That's how I got 30. Then the outside terms, minus 2 root 5, the inside terms, plus 3 root 5, and then the last two terms multiplied is minus 1. So you're ending up with 30 minus 1, which is 29, and then minus 2 plus 3 is plus root 5. Really simple. This one down here, again, now that we're getting into territory which you should have met before, but this is to do with a surd underneath. The surd is in the denominator, and we do this thing called rationalizing the denominator, which you definitely should have heard of at this stage of your GCSE career. We're looking at getting rid of this root underneath. So what do? You multiply top and bottom effectively by a root to get rid of this thing underneath. So in this case, it's going to be root 12 that we're multiplying. So you multiply top and bottom by root 12 just to get rid of this horrible root here. Now I'm using product notation here. You may not have seen this before. So product notation is what I'm using. So I've got a little dot here. I could put a multiply sign, but I tend to use product notation. It just means the same thing, so I'll put a multiply sign just for simplicity reasons. Root 12 times root 12 is 12. And then on the top I would have 6 root 12, and of course these two things cancel out a little bit, so it gives you half root 12. So that's going to be where you get to. Now it's asking for n as an integer, and so this is slightly confusing because you're sort of trapped in a situation where you're thinking, well, how can I simplify this? But underneath this square root here, we have the square root of, well, 3 fours is what that is. 3 times 4 is 12. And I know that the square root of 4 is 2. So I could pull the 2 outside of my square root. So root 12 is the same thing as 2 root 3. So effectively this half root 12 here is 2 root 3 over 2. And then those two things would cancel, leaving you with just root 3. So when it's asking for n as an integer and just in the form of square root of something, the answer is square root of 3. So you've got to do this bit of simplification to get this right. So just do that once more. So root 12 is the same thing as 2 root 3, and if we're halving root 12, that's half of this, half of 2 root 3. Well, that's just root 3. So hopefully you can see that and understand it. Moving on, we've got question 6 here. It's slightly quirky. Slightly different type of question. It's talking about a geometric sequence. What's a geometric sequence? You should know, but a geometric sequence is a sequence that has a common multiplier. So for example, I'll just give you an example of a geometric sequence. 1, 2, 4, 8, so on would be a geometric sequence because we've got something multiplied. Rather than having a common difference, we've got a common multiplier, a common ratio. So times 2, times 2, times 2. So this is a geometric sequence. When you've got a common ratio, a common multiplier, we call these a geometric sequences. The other type of sequences that you will know will be sequences like this, where you have 1, 3, 5, 7, 9, for example, where you have a common difference. They're called arithmetic sequences. So you've got geometric sequences and arithmetic sequences. You will know that with arithmetic sequences, you can write them in terms of n, an nth term. You'd have learned about an nth term. You can do the same thing in geometric sequences too, but the key thing is they have common multipliers. So back to this question, it's saying that this is a geometric sequence and these are the first 3 terms. And it's asking you to find the value of x. Now the fact that it's a geometric sequence and these are the first 3 terms means that this one divided by this one and this one divided by this one must be the same, because it's the same multiplier from each thing. So I'm going to write that little phrase in words. So I'm going to write that we know that the 1 over the square root of x minus 1 is equal to the same thing as root x plus 1 over 1. In other words, that divided by this is the same thing as this divided by that. That's what this is saying. Now when you get to this form, we can actually solve this equation a little bit by multiplying up, finding a common denominator. We can do a little bit of cross multiplying, so I can multiply this top bit here by root x minus 1 and multiply this here by 1. We can do a bit of cross multiplying. So hopefully you understand that I could rewrite this as root x plus 1 and then root x minus 1. So all I've done there is I've just multiplied both sides by root x minus 1. So that's how I got this here. So I've multiplied this top bit by root x minus 1. So be aware of that. It's called cross multiplying. Cross multiply that out. Now this here is a pair of brackets. We can multiply that out like previous questions. So we're going to do our first 2 terms multiplied makes x, and then outside terms multiplied makes minus root x. Inside terms is plus root x, and then last 2 terms multiplied makes minus 1. These 2 are going to cancel, leaving you with x minus 1. So 1, which is on this side, is equal to x minus 1 here. Now what does that mean? It means x is 2. And it's asking you to find the value of x. So x is 2. That's my answer. Down here it says, show that the 5th term of s is 7 plus 5 root 2. Okay, so this is quite an interesting twist on the problem. So it's saying, now that you've got the first 3 terms, these are the first 3 terms, work out the 5th term. Well, I want to go back to my example up here. Here are the first 3 terms of the geometric sequence, for example. We know the common multiplier is 2. If I wanted to work out the 5th term, which I already know is going to be 16, how would I be able to do that from the common ratio? Well, I can, if I know it's times by 2 each time, I can say, well, look, take this 3rd term, multiply it by 2, and multiply it by 2 again. So multiply it by the ratio, and multiply by the ratio again. So 4 times 2 and times 2 again, that would get me my 16. 4 times 2 times 2. So if I can work out my common ratio, the number I'm multiplying each time, I just need to do that twice times by my 3rd number. So back to this again. Now that we know what x is, we know that x is root 2. We can write the first 3 terms of my sequence. So the first 3 terms of my sequence were root 2 minus 1, because we worked out that x was 2, 1, and then root 2 plus 1. These are the first 3 terms of my sequence. Okay, so a bit like up here again, this is like the equivalent of my first term is there, and my second term is there, and my 3rd term is there. I'd like to work out what the common ratio is, what I'm multiplying by each time. So the easiest way of doing that is to do root 2 plus 1 divided by this. So that's just root 2 plus 1. So the multiply from this 1 to here is root 2 plus 1. So I'm multiplying, my common ratio would be my multiplying by root 2 plus 1 each time. Because to get from there to there, I'd have to multiply by root 2 plus 1. So this is my common ratio. Up here it would be 2. Okay, so down here it's root 2 plus 1, slightly different expression, but it's the same sort of principle. Now, just like in the previous example, I'd like to take my 5th term. So this is my 3rd term. So to get to my 5th term, I've got to take this, multiply by this, and then multiply by this again. So in other words, I've got to do root 2 plus 1, which is my third term, and then multiply it by root 2 plus 1 squared. Okay, so this times this, and then times this again. So root 2 plus 1 times root 2 plus 1 times root 2 plus 1. It's root 2 plus 1 cubed, effectively. I'm going to use a pair of brackets to work out this, because I'm not terribly comfortable multiplying these out quite quickly. So I'm going to try and work out what root 2 plus 1 all squared is. I'll do it over here. So again, this is just a pair of brackets. We can write it out. And again, root 2 times root 2 is 2. Outside terms, root 2. Inside terms, root 2. Last two terms is 1. So I'm ending up with 3 plus 2 root 2. So that's what this makes. So 3, so 2 plus 1, 3, and then 2 root 2 there. So 3 plus 2 root 2. I've got this root 2 plus 1 here. So I'm ending up with an expression like this. There's a lot of working for this question. So I'm multiplying these now. So again, go about it the same way. So first two terms, 3 root 2. Outside terms would be, got to be careful with my signs here. So it's 2 root 2 times root 2. So it's going to be 2 root 2 times root 2. So I'll leave it like that for now. The inside terms would be 3, and the last two terms would be 2 root 2 again. So it doesn't matter that it's a bit back to front. We can still use the full method to do it correctly. And then, well, this bit here, so root 2 times root 2 is 2, and 2 times 2 is 4. So I'm going to end up with 3 root 2 plus 4 plus 3 plus 2 root 2. Okay, that's my expression so far. 3 root 2 plus 2 root 2 is 5 root 2. And then 4 plus 3 is 7. So move that over for you. So 5 root 2 plus 7. And that is the expression they're trying to get you to prove. It's just a bit, it's back to front. You could rewrite it. But 7 plus 5 root 2, this is 7 plus 5 root 2, just in a slightly different order. So I'm going to write that out just for completeness sake. 7 plus 5 root 2 there. And I'll put a little pair of lines to show I've proved it, or I've shown it. This question here is, again, similar sort of question, asking you to multiply out, again, surd expressions. So this is asking for a squared minus b squared. So a squared, first of all, root 8 plus 2 times root 8 plus 2. We need to multiply that out, so that's just going to be, first two terms multiplied is 8, outside terms 2 root 8, inside terms 2 root 8, last two terms is 4. So you've got 12 plus 4 root 8. Now, I know that root 8 is 2 root 2, so I'm going to rewrite this as 12 plus 8 root 2. Just a reminder, root 8 is 2 root 2. How do I know that? Because root 8 is 2 times 4, and if you square it to 4, you can bring that outside the bracket again. So you should remember this, but just in case you don't remember, that's what it is. So that's going to be the a squared part. So root 8 plus 2, that's the a squared part. We're going to do b squared now. So underneath I'm going to do root 8 minus 2 all squared. So root 8 minus 2 times root 8 minus 2, same thing again. So first two terms, outside terms, inside terms, and then last two terms. Be careful with the signs. Minus 2 times minus 2 makes plus 4. And then we're ending up with 8 minus 4 root 2. Sorry, apologise, that should be root 8. 4 root 8 here. So 8 minus 4 root 8 plus 4. And that's going to be equal to 12 minus 4 root 8. And again, root 8 is 2 root 2. So it's going to be 12 minus 8 root 2. So they're very similar expressions, 12 plus 8 root 2 and 12 minus 8 root 2. And then we're going to do the same thing as it's asking for. It's asking for a squared minus b squared. So this phrase minus that phrase. So we're going to write that down here, over here. So 12 plus 8 root 2, and then minus 12 minus 8 root 2. Now I'm putting brackets in deliberately, just to show you where they've come from. That's the a squared bit, that's the b squared bit. a squared, b squared. Put in brackets in deliberately so you can just get a feel for the signs here, because the signs make a difference. So you've got 12 minus 12, well that's just nothing. 8 root 2 minus 8 root 2, so the two minuses make a plus, so you're going to end up with 16 root 2 when you make those, when you do that sum. So when it's saying that c has to be an integer, c is going to be 16 here. This one here, question 8, so again, this is looking really horrible. It's asking you to write it in a certain form, so that's good, it's got something to aim at. But looking at this first, you need to sort of think about, right, okay, let's just work with the denominator for now. Let's just work for this bit for now, and then we'll come back to the rest in a second. So this bit underneath, 1 plus 1 over root 2. Well, just like in a set of fractions, if we think of this as 1 over 1, you would need to find a common denominator. So common denominator here would be root 2. And then what have I done to the bottom of that to get to that? I've multiplied it by root 2, so what do I do to the top of this? I multiply it by root 2. I haven't done anything to the second one, so it's just going to stay as 1, but I've got a slightly different looking expression now. I'm going to put that in a pair of brackets. Now the actual fraction is 1 divided by this, so it's 1 divided by that. So it's 1 divided by this expression, root 2 plus 1 over root 2. And again, if you've revised fractions, divisions, you'll know that if you're dividing fractions, you change this to a multiply sum, and you flip this upside down, so keep change flip, or keep flip change, whatever you've learned. You would do 1 multiplied by root 2 over root 2 plus 1, so it's just doing it just like a fraction. And then again, thinking of this as 1 over 1, you'd have root 2 over root 2 plus 1. Still not quite there yet, because we've got a surd in our denominator, so we need to rationalise that denominator. So we've got to multiply by root 2 minus 1 and root 2 minus 1. Why is it minus 1? It's always, you always look for the, to rationalise the denominator, you always take, invert the sign of the second part of it. So if it had been 1 plus root 2, then what you'd multiply is 1 minus root 2. But as it's root 2 plus 1, you do root 2 minus 1. So you always invert this sign here. So the fact that it's root 2 plus 1, you're going to multiply by root 2 minus 1, because that effectively that will conjugate out. You'll have some simplification that you can do. So let's look at that bottom part. So root 2 plus 1 times root 2 minus 1. You can see how that creates a rationalised denominator. So we're going to multiply that out using fractions, using 4 method again. So root 2 times root 2 is just 2. Outside terms minus root 2, inside terms plus 2 root 2. That's why the sign has to be different, because these two will cancel, and then minus 1. So these two cancel, leaving you with 2 minus 1. So that's just 1 underneath. So this bit over here, that's just going to make 1 underneath. And on the top, I've got root 2 times root 2, that's just 2. And then root 2 times minus 1, well that's just minus root 2. And it's over 1, as we just discovered, so that's just 2 minus 2 root 2, which is what it was asking me to prove. So just the final 2 lines there to show that we've done it. This bit under here is a very similar question, but just in a slightly different format. So again, it's an unrationalised denominator, I've noticed that, and there's a pair of brackets on the top, which I'm going to multiply using the 4 method. So we're going to use the 4 method on the top, so 6 sixes, 36. Outside terms, 6 root 5. Inside terms, minus 6 root 5. Last 2 terms, minus 5, because root 5 times root 5 makes 5. And on the top I've got, on the bottom, sorry, I've got root 31. This on the top of these two will cancel. 36 take away 5 is 31. So I've got 31 over root 31. And again, I'd like to rationalise this denominator, so I'm going to multiply it by root 31 over root 31. A bit like the earlier example with root 12 over root 12. And then these two things will make 31. So I've got 31 root 31 over 31, and then this cancels, leaving with root 31. So nice and simple. Okay, you've got to revise rationalising denominators. A lot of this is not making sense. Rationalizing Denominators is the chapter you want to look at, so go back and have a look at that chapter again. One more to do, one last one now, last question, which is this one. And again, it's quite an interesting question because it's got an unrationalized third here underneath. So the first thing we're going to do is look at this, but we're going to look at it like a pair of fractions, just like a pair of fractions essentially. No different from normal fractions, except we're just working with these horrible things. So if we were to find the common denominator, it would be 5 root 3. So I've just multiplied these two things together to get 5 root 3. What have I done to that to get to this? I've multiplied it by root 3. So what do I do to the top bit? I multiply it by root 3. Root 3 times root 3 is just 3. And then what have I done to the bottom of this to get to this? I've multiplied it by 5. So what do I do to the top of that? Multiply it by 5. So it's plus 10. So 3 plus 10. That's going to be 13 over 5 root 3. And again, this has an unrationalized denominator. So we're going to rationalize that up by multiplying by root 3 and root 3 on top and bottom just to rationalize it up. So we're going to have essentially 13 root 3 and then 5 and then root 3 times root 3, well that's just 3, so 3 5s are 15, so it's 13 over 15 root 3, which when it says in the question A is a fraction and it's giving it in the form root 3, so the fraction we're looking for is 13 over 15. Okay, so again, just rationalise the denominator there in the last stage. Okay, that's it for this video. This was manipulation of surds. I hope you found that useful. I do wish you all the best of luck for your exams in the summer. Keep watching the channel because I'll keep adding these videos routinely, so do tune back in a week or so. You'll probably find a few more up. Good luck for the summer. I hope to see you soon, and have a good rest of the day.